Bright Duty. Every student matters.
Hello dear students, today we will be taking up the chapter Sources of Energy. Now we know that as per law of conservation of energy, energy can neither be created nor be destroyed. That means during any physical or chemical processes or reactions, the total energy remains constant. It can only be converted from one form to another form. Then why it happens that we talk so much about energy crisis? The prices of fuels are on the rise, the consumption is increasing, everybody is talking about the lack of energy resources, everybody is talking about that we should reduce or limit our consumption. Why is it so? The reason is not difficult to understand. Let us take a few examples. We know that as per I have said, law of conservation of energy states that energy can neither be created nor be destroyed, but it only converts from one form to another. Taking an example, if I carry a plate and throw it from some height. Now, because of the height, this plate has potential energy. Potential energy, we must be aware that it is the energy of a body by virtue of its height or position above the ground level. So, this plate is having potential energy because of its height. When I allow this plate to fall down, what happens is this potential energy gets converted into sound energy. We just listen to a clatter of sound produced by this falling plate. Similarly, taking another example, for example, we take a candle, a wax candle. This wax candle, when I burn this candle, what happens is the chemical energy which was present in this wax is converted into light energy plus heat energy, right. So, in the burning of a candle, we see that the energy transformation takes place in the form of conversion of chemical energy into light and heat energy. Now, if I want to reciprocate this particular phenomena, if I try to somehow gather this light energy and this heat energy, will I be able to restore it back to the chemical energy? No. Taking another example, if I heat up water to a particular temperature, for example, I boil it up or I heat it up till 75 degrees Celsius. Now, I allow this particular water, this hot water, to get cooled at room temperature, and this particular water cools off to 25 degree. How it is getting cooled off? It is getting cooled off because the heat energy of this water was getting absorbed into the atmosphere, the surrounding environment. Now, the water has reached 25 degrees Celsius mark. Fine. If somehow I am able to collect this entire heat lost in the atmosphere, will I be able to raise the temperature of water again back to 75 degree? No. So, all these discussions and examples tell us that energy is getting converted from one form into another form. But important thing is, we need to see that there are certain usable forms of energy and diffused or non-usable forms of energy, and that is the reason why this energy which has been converted from usable form into that unusable form gets wasted, and that is the main reason why we talk about the energy crisis situation. Fine. we have seen that every day since waking up in the morning till sleeping at the night, we use various forms of energy, various sources of energy for doing our every work, day to day work. For every activity that we are doing, we are using up our muscular energy. From where did that muscular energy come up? That came from the chemical energy of food that we ate. Fine. Next, we see in all the weathers we use electrical energy for doing lot many things. For cooking food, we need the chemical energy of fuels. So all these are the various types of energies we require and use every day. Now, have we ever wondered why we are using these types of energy? Of course, for doing our work, but why we have selected a particular source of energy for doing that thing? For example, I don't utilize my muscular energy for cooking food. I don't use the chemical energy of food in order to iron my clothes or to run the fans. For that, electrical energy is used. So, we need to choose a good source of energy for doing a particular work. And that choice of a good source of energy comes by asking a few questions. So, we use various forms of energy in our day to day life. Fine. And we need to select which particular source of energy we should use, and for that, for finding the good source of energy, we need to ask a few questions from us. That is, does it produce any smoke while burning? Is it harmful? Does it produce any poisonous gases after burning? Is it giving good amount of energy, because this is what we are requiring it for? Is it easily available? Is it easy to transport? Is it easy to store? And of course, is it economical or not? So, there are certain factors, certain reasons which basically decide which particular source of energy is a good source and may be used to provide energy or not. So, there are certain criteria or features or characteristics of a good source of energy. Let us see what are the various features. First of all, whatever source of energy we are using it to obtain energy. So, the first criteria for selection of a good source of energy is that it should provide large amount of energy. It should provide large amount of energy per unit mass. Now, there is a specific term for this which is known as calorific value. Try to understand what is this calorific value. Calorific value means the amount of energy liberated by burning unit mass, means 1 gram of a particular substance or a particular fuel. So, what is calorific value? It is the amount of energy liberated by combustion of 1 gram of a fuel or a substance. Now, this calorific value is expressed as kilojoules per gram. Let us take an example. I say that calorific value of wood is 6 to 8 kilojoules per gram. What does this statement mean? This statement means that if I burn 1 gram of wood, I will get 6 to 8 kilojoules of energy, right? Similarly, when I talk about petrol, if I am talking about petrol, the calorific value is approximately 46 to 48 kilojoules per gram. Means when 1 gram of petrol is burnt, then the amount of energy produced is 48 kilojoules. So when I am selecting about a fuel, I need to see that which particular fuel is providing me maximum possible amount of energy upon burning, because that is my first purpose of using this particular substance as a fuel. The more is the calorific value of a fuel, the better fuel it will be. Fine. But you need to remember that it is not the only consideration that we take. For example, if we talk about hydrogen, hydrogen has a calorific value of 150 kilojoule per gram. That is considered to be the maximum among all the known fuels right now that we are using or having, right. This hydrogen has the maximum calorific value. It is 3 times to that of petrol or the household cooking gas, petroleum gas that we use. But still this hydrogen is not used for domestic cooking. Why so? The reason is this hydrogen burns with an explosion. Now I don't want in our kitchen something which explodes. So even though it has get high calorific value, even though it is providing a so much large amount of energy, it is not safe to use, and that is why hydrogen is not used as a domestic fuel. So my second consideration while choosing a particular fuel is it should be safe. It should be safe to use. Now when it comes to safety, there are certain points. First thing, like hydrogen, it burns with an explosion, I don't want it. Second thing, if this fuel produces some poisonous gases like sulfur dioxide or carbon monoxide or nitrogen dioxide gases, among these sulfur dioxide is a choking gas, carbon monoxide is a suffocating gas. So these gases are poisonous gases. I will not prefer such substances even though they are providing a good amount of energy, even though they have a high calorific value, but still I will not prefer these because of this particular reason, that they are not safe to use. They are producing poisonous gases upon combustion. Fine. Third important factor is that it should be cheap. It should be easily available, easily accessible. I don't want a particular fuel which is very expensive, because that will add to my cost, right. That will be a burden on my pocket. So I will prefer the fuels which are comparatively cheaper and are easily available. Plus I prefer a fuel which does not produce any smoke. It should not produce smoke, it should burn smoothly and leaving behind no ash. No ash should be left. Fine. That is why we prefer gaseous fuels or liquid fuels as compared to the solid fuels, because all the solid fuels like coal or wood, they all leave behind a lot of ash, they all produce a lot of smoke, right. The household cooking gas that we use, LPG, in our cooking cylinders, we don't see any kind of smoke being produced out there, we don't see any kind of residue being left, and that is why it is a good fuel and is being used in our houses. Another factor which we consider is they should be easy to store, handle and transport. There should not be much difficulty while storing them or transporting them. So they are also good fuels. Now students, there is one more thing you need to remember, that is the fuel should have a proper ignition temperature. Now what exactly is this ignition temperature? Ignition temperature means the temperature at which a particular substance is ignited or it catches fire. So ignition temperature is the temperature at which a substance catches fire. Now, when we talk about a good fuel, we want that fuel to have a proper ignition temperature. When I mean by saying proper ignition temperature, I am elaborating it. Proper means it should not have a very high ignition temperature. Like if a fuel has ignition temperature of 300 degrees Celsius, in that case I need to burn 5 or 10 kilograms of coal just in order to make this fuel catch fire. So I don't require that kind of fuel. Or if the ignition temperature is too low, 12 or 10 or 15 degree, in that case it is much less even than the room temperature. I don't want that fuel which I need to refrigerate. And if somehow there is no refrigeration available, this fuel will catch fire on its own. So both the cases are not acceptable. So we require a fuel which has an appropriate, a proper, a suitable ignition temperature. So these are a few criteria on the basis of which we see, we select, we choose a particular source of energy. Right? Let us rewind a bit. Let us see what are the various sources of energy that we are talking about. Alright. So the good source of energy should be such that it should provide large amount of energy, that it should have a high calorific value. It should produce more energy after burning unit mass of it. Next, we talked about that it should be safe. It should not produce any kind of harmful gases or poisonous gases. It should be cheap and easily available, right? Then it should not produce any smoke, or it should burn smoothly, and it should not produce any ash. It does not produce any smoke, then it is considered to be a good fuel. Then it should be easy to store, easy to handle, and easy to transport. And it should have a proper ignition temperature. Fine. So these are a few characteristics that are considered while choosing a good source of energy. Right. I hope you have understood it well. Thank you so much.